recommend that. If you're still struggling with the unit circle, start putting in effort to that now. So I'm not going to go over the unit circle again because we've already talked about it. Okay, so one of the two things that you use in trig all the way back in geometry is, or at least most of you, we use an acronym SOFOTOA, and we've already needed to refer to it once so far this year. But now we're going to talk about it, how to use it to find side lengths, and how did you use it to find angle measures. So the two ways that you used it in geometry are definitely a big part of right triangle trig, which is what we look at. This is also very important for ACT as well. So I said right triangle trig, so it does have to be a right triangle. And an example question, or I'll do two examples in here of how we could find a side length. Okay. So let's say I knew this length was 5, and I wanted to know this length. Well, that's not enough information unless you know one of these acute angles. And normally you know this one because it's often centered at origin. So let's say this angle is 21 degrees. So you have to think about whether you should set up a sine equation, a cosine equation, or a tangent equation. Only one of those is going to be useful here. Because I know the length of the opposite side. So I've got to pick an acute angle too. We never look from the right angle, that's not helpful. But I've got to pick an acute angle. So I guess I can subtract these two from 180 and find that angle, and I can look from that angle, but most people aren't going to do that because that's extra work. So looking from this angle, directly across, I know the opposite. So I definitely want to make that part of my equation. And I'm trying to find, what is this one? Jason. So sine is great if you want to pair up opposite hypotenuse. Not this case. Cosine is great if you want to pair up adjacent hypotenuse. Not this case. Tangent is to be used when you're trying to use opposite and adjacent together. And so I can say the tangent, looking from this angle, is the opposite length over the adjacent length. Tangent is always opposite over adjacent. Cosine is always adjacent over hypotenuse, and sine is always opposite over hypotenuse. The letters are arranged in that way to get you that. Well, now we have an equation that we can solve for x. Okay. I don't usually go through this many algebra steps, but I can multiply both sides by x, and then I can divide both sides by the tangent of 21. But really all I'm doing is switching x and tangent of 21. So my exact answer could be x is 5 divided by the tangent of 21. And depending on what that question is supposed to represent, somebody wants to know the height of the building, saying 5 times the tangent of 21 degrees is not real helpful. Or 5 divided by, sorry. So oftentimes we then go to our calculator, we check to make sure that it's in degree mode, and then we can type that in and say, okay, x must be about 13.025. If you do more work, which sometimes in your homework it'll ask you to find all the sides and all the angles, how big would this angle be up here? The angle I didn't have. 180 minus this, minus this. If you do that extra work, you've got an idea if your answer is realistic. The side length opposite 21 degrees should be quite a bit smaller than the side length opposite 69 degrees. 69 is a bigger angle, so that forces it to open up more and have a bigger side. So if I got an answer near 5 or less than 5, definitely something wrong. Maybe if I didn't solve that equation correctly, and I thought it was 5 times the tangent of 21, there's no way that length could be sides. This is opposite of your angle, so this has to be your side. Okay, so you get stuff like that to find side lengths. Is that about what two sides you have? Figure out which trig function lets you pair up those two sides. And sometimes you just multiply both sides by numbers. You're trying to do under division. Or in this case, I had to multiply both sides by x and divide both sides by 21 to solve for that. Okay, so there's an example finding the side length. You guys remember doing that? Geometry. I think this is one of the few things that you can predict that will be on NCT. So if you don't need to know for this class, but also for that. Also, you can do it to find angle measures. So again, this is right triangle trig, and everything we do, at least until about January, is about right triangle trig, so it has to be a right triangle. And so, obviously, if I know this angle is 21, like the last question, I could just subtract 90 and 21 from 180 and find that. And that's great. When you know the other two, do the easy path. That all triangles always add up to 180 degrees, assuming you're talking about plot geometry. But what if I don't know one of the acute angles? A different way that you use SOHCAHTOA is maybe you know, maybe you know this length up here is 8, and you know this length up here is 10. That's enough information to figure out how big the angle is. In relation to theta, 8 is it the opposite side, adjacent side, or let me move this 10 so it's not the same. This is opposite, it's directly across. And if I put the 10 there, where I moved it to, the 10 is the. Okay. So the point of memorizing how to spell SOHCAHTOA is tangent doesn't apply here. Tangent uses opposite and adjacent. I'm going to use opposite and hypotenuse. Cosine doesn't apply here because it uses adjacent hypotenuse. This would be a case where I want to do sine. Because sine lets me pair up opposite over hypotenuse. Now, it was a little bit different here because you're solving for something different. And we will get really in depth with this later. But if instead of plugging in an angle, we're plugging in a ratio, we're plugging in the opposite information. This is actually an inverse function. So you're not going to use the regular sign when you find an angle. You want the inverse sign. And to get that on your calculator, you just have to hit the second button first. So second sine, opposite hypotenuse is 8 over 10, or 4 over 5, whatever. And my calculator is in degrees, so what it's telling me is that angle would have to be approximately 53.130 degrees. So not much work to be had, but those are both important skills. So finding side lengths, set up an equation with SOHCAHTOA, finding angles, set up an expression with an inverse trig function. Sine is always opposite over hypotenuse, cosine is always adjacent over hypotenuse, and tangent is always opposite over adjacent. Okay. Some of your book questions will be about a triangle, of course, and maybe they give you a couple links. They'll either draw a picture for you, or they'll give you the links, and you should probably sketch the triangle. And the directions will say, well, go and find the exact value of the 6 trig functions. So we're going to talk about angle B. Because it does make a difference whether you're looking from angle B or you're looking from angle A. Always, never the right angle, always one of the two angles. So that might be like, they want to know what's the sine of B, what's the cosine of B, and tangent, and the 3 reciprocals. They're going to ask you for all 6. Now, we only do that for a few more weeks. At some point, we just ask you the 1 or 2 that you need for the question. But right now, you need to practice finding all 6. Any one of those 6 can be important. Okay, so if I'm looking from angle B, what is the 5? Because it's biggest side, opposite right angle. What is the 3? Adjacent. So, without doing any more work over here, without adding to my picture, if I only know adjacent and hypotenuse, which trig function do I know? Because cosine is adjacent over hypotenuse, 3/5. And, you know one more, secant, because that's the reciprocal of cosine. So as soon as you get cosine, you get secant to flip it over. The other 4 require me to know the opposite side, right? So, I'll just have a look. I'm not going to be able to give those answers. Right, and that's a pretty common thing that we'll need for a lot of these questions. 2 or 3 sides of a right triangle, that will be Pythagorean theorem. And I will warn you, sometimes you guys hear Pythagorean theorem and you say, oh yeah, I've done that a lot. You guys will make mistakes on this if you don't listen to what I say here. Hypotenuse has to be C. Whichever leg you want to call A, and whichever leg you want to call B, doesn't matter. But if you don't plug the hypotenuse in for C, Pythagorean theorem doesn't work. Seems like I'm overstating that, but I promise you that's going to be a lot of mistakes. Okay, so the other leg, which I'm calling A, is A squared plus 9 is 25. So I can subtract 9 from both sides and say that A squared is 16. I can take the square root of both sides and say that it's plus or minus 4. But since I'm really talking about lengths here, I'm really only interested in plus 4. Is there any other way to get that one? What was that? Right, so the most common Pythagorean triplet is a 3, 4, 5. So that's a hint you want to know because it's going to save you from doing Pythagorean theorem 50 times this semester. And in 3, 4, 5 triangle, the 5 have to be the hypotenuse. If the 5 was over here, it would be over 3, 4, 5. Okay, so now I've done the hard work. Sine, so the total reminds me sine is opposite over hypotenuse. I can flip it for its reciprocal function. So if someone tells me that tangent is opposite over adjacent, and I can flip it for its reciprocal function. So we're leaning on SOHCAHTOA to remind us of the ratios. Sometimes we do Pythagorean theorem to find the third side. Sometimes we have to set up SOHCAHTOA equation to find the side length. Sometimes we have to set up an inverse SOHCAHTOA expression to angle. So that's a lot of what you're focused on is going to be. Okay? Those types of questions, making sure that you have those skills done very well. I should also warn you that 4.3 is kind of split into 2 sections. So the book assignment is questions mostly like these. And that's what you'll dive into today and hopefully iron out most of any problems that you have. 4.3, we also do trig identities, which is one of the hardest things that we do this semester. But we give you like a full day to work on. Also, some of you guys should have done it last year. So if you did that, that would be probably easy. Okay, so not for next class, but I think the very class after that, there are some identities that you have to memorize. So as I said, the second half of this unit is about proving trig identities. And you can't prove trig identities if you don't know the basic identities to apply. So if you look at your assignment sheet, there's something that says like basic trig identities quiz. And it's not using these yet, because you will use them too, but it will be just memorizing. So you don't have to memorize them between now and next class, but the class after you will. Some of the book questions will ask you to refer to these as well. Now, in all of these, we've already talked about some of them. Last class we talked about, I guess 2 classes ago, we talked about the trig functions in terms of x, y, and r. So I drew a picture, I drew an x and y axis. And And so you already have that on your notes, but I will remind you of those. Sine is y over r. That's why sine equals y when we're talking about the unit circle. Cosine is x over r, which is why the x values on the unit circle end up being cosine values, because there's one. Tangent is y over x. And if you know those three, you know which functions are reciprocals of which, you can just flip over as necessary. But we do want you to know those in terms of x. Sometimes that makes questions easier. So, I didn't tell you that you had to study it for a quiz yet, but at least it's not. We've also already talked about the reciprocal functions. Sine of an angle is the same thing as 1 over the cosecant of that angle, and vice versa. Cosecant equals 1 over sine. Cosine is reciprocal to secant. Cosine is the same as 1 over secant. Or secant is the same as 1 over cosine. It works both ways. Feel free to write it both ways if you want. And tangent is reciprocal with cotangent. Hopefully you know those already for today's course. But we will ask you that, and we will need to know those for the transfers. Alright, so that is not new. Let's jump down here to the quotient identities. So one of these, we should have been leaning a lot. You may not recognize it as the quotient identity, and you also have that in the notes. But that is, how do you, or on your quiz, how did you go about finding tangent values? And that is the quotient identity. Tangent is sine divided by cosine. Technically, cotangent is also quotient identity, but it's just a reciprocal, so because tangent and cotangent are reciprocals. So that's not really new either. I will add that even and odd, I barely said anything about. But do you happen to remember? I said there's only two functions that were even. Do you remember what those two functions were? Cosine is reciprocal. What that means is, for cosine, whether I plug in a positive angle or a negative angle, I get the same thing. Secant is also even, so it works the same way. So did you have to memorize that yet? Probably not. It was helpful if you did. But these are the even functions. So they have a similar pattern to them. And then I said the other four are odd. So if you know what it means to be odd, that's all you have to memorize. If you don't know what it means to be odd, then you got one extra step. But the sine of t is not equal to the sine of negative t. Only equal if you change the sign. Same with its reciprocal. Only equal if you change the sign. Tangent's a non-function. So plugging in the opposite angle gives you the opposite ratio, and also cotangent. But you're not really memorizing these four things. You should be looking for the pattern. All four of these guys are odd functions, and that's why they're all made the same. But you will need to have it memorized for that one time. So that's still pretty new, but not 100%. Okay. On to the cofunctions. This one is completely new, and this one, to be fair, doesn't have much context to it yet. But you're going to have questions that say something like, even in the book assignment, they'll say like the cosine of 90 degrees minus theta, or the cosine of pi over 2 radians minus theta, that's the same thing, equals what? And so if you know the cofunction, it's usually pretty easy. But cosine, and you're going to see a lot of pattern here, is that cosine is a cofunction with sine. So all of that just equals sine. Actually, it works the other way as well. Sine is co-functions with cosine. So if you took a right angle, subtracted theta, it gives you its co-function. If that's cosine, you get sine. If you get sine, you get cosine. Okay, so once you know the pattern, you just have to memorize that sine and cosine are co-functions. Also, cosecant and secant are co-functions. And it works both ways. This then leaves us tangent and cotangent co-functions. So I'm not trying to get hung up on how big the formula is. And just that they all look the same. These get paired up, these get paired up, and these get paired up. That will help us with graphing. I can promise you, today, one of you are going to ask a homework question, and it's going to look something like this. It's going to be like, what is the secant of pi over 2 minus theta? And you're going to try to be making sense out of this, and you don't need to. All of this is equal to cosine. You're probably going to know it. And I often say on the quiz, I think you want to know something. Only if you have those memorized. So, yeah, just to be clear, you don't have to memorize this between now and next class. You will. So that was new. And so the last one, this one is super important. This is one that we will use all semester long. Or the Pythagorean identities. Alright, so let me show you where the first one comes from, just so you have some context. I'm just to draw a circle like this. Remember what the equation of a circle looks like? It's like x minus h squared plus y minus k squared equals r squared. You understand that? And it's just that the h and k make up your center. So if I centered it at 0, 0, for this, for my example, you don't have to copy this down, but that means h and k are both 0 and 0. So if I plug in 0 here, I get this. If I plug in 0 here, I get this. Okay with that? And that gives me the radius squared. So this you could have seen in geometry class. This is a circle centered at 0 with the generic radius length. Well, there's only one step past that before you get to the first Pythagorean identity. In trig, we like to talk about the unit circle, so we like r to be 1. And when r is 1, what is equal to x? One more time. When we're talking about the unit circle, what values can you get from the x values? Cosine values. So this is like cosine squared. X squared is like cosine squared. If we're talking about the unit circle, cosine equals x. So that's like cosine squared. And if we're talking about the unit circle, what is y equal to? So that's all the first Pythagorean identity that you'll need to memorize. It's really an equation of a circle that has a radius of 1. Instead of saying x, we say cosine. Instead of saying y, we say sine. So you can write it like that if you want to. I don't know. Most people tend to say it the other way, though. Sine squared theta plus cosine squared theta equals 1. Okay, so that's the first one. That's the main one. And I had just yesterday, calculus student, we had a test today, on test review, reminded them that this is something that they need to know, even though it's not calculus. And she was, on top of studying everything else, she had memorized these three that I'm about to give to you for the class, but she had forgotten the other two. And I don't know, maybe she just wasn't here that day, or her teacher didn't show you. But there's a trick to find the other two where you're not actually memorizing the three. So if you took all of these and you divided everything by sine squared, you get the second Pythagorean identity. So if I divided this by sine squared, I get 1. So anything divided by itself is 1. If I divided this by sine squared, I get cotangent squared. Cosine over sine is cotangent. Cosine squared over sine squared is cotangent squared. And if I divide this by sine squared, I get cosecant squared. 1 over sine is cosecant, and 1 over sine squared is cosecant squared. So she had not seen that trick before, so she had just memorized this all throughout the first semester of last year, and that works. It's just not a good skill long term. She had forgotten. Or you could take this first one and to derive the second or the third one, you could instead divide everything by cosine squared. So if I took sine squared divided by cosine squared, that would be tangent squared. Sine divided by cosine is tangent. Sine squared divided by cosine squared is tangent squared. To divide this by cosine squared divided by cosine squared is 1. So anything divided by itself is 1. And then also divide this by cosine squared. So what do you think 1 divided by cosine squared would be? Secant squared. 1 over cosine is secant and 1 over cosine squared. So there's some tricks. At the end of the day, you have to have memorized. So if you just memorize it, try it out, that's great. But really, all you have to do is memorize the first one, divide them all by this to get the second one, or divide them all by this to get the third one. So when we get to that, which I will talk about next class, these are the things that you'll have to memorize. It just shows that you have those memories so that you can hopefully use them. So, questions from the top half of the notes. I've seen that stuff before, but we've got to make sure that you're good with it, making mistakes, and figure out everything you may have forgotten. This you'll need to memorize at some point, and you'll need to refer to a few of those in your assignment. And on your assignment sheet then, so we're going to start. So this doesn't really need to be completed until day 8. Today is day 7.